So this video is going to go through the 2017 B2 question. It tells us the image on the right shows a playground unit incorporating two planar surfaces which intersect as shown to represent the bow of a boat. The unit also includes a triangular seat and two circular portholes. Figure B2 below shows the plan and elevation of a model of the unit. The horizontal and vertical coordinates of the two intersecting planes ABCD and ABEF are also given. So you can see you have your coordinates here, and there's your elevation and your plan. Part A then asks you to draw the plan and elevation of the two intersecting planes ABCD and ABEF. Part B then determine the dihedral angle between the planes. So if we look what's common between the two, we can see that AB, so the line of intersection will occur along here. So we'll be looking out here somewhere for our dihedral angle. Part C then, determine the true shape of the surface ABCD. On the true shape include a diameter 20mm circle for the porthole, given that centre is 30mm from the line AB and 50mm from the point D. So basically we're going to have to find the true shape of that surface there. So in order to get a true shape we'll need to find the true length of all the sides. And then using that information then, we'll be able to draw the porthole measuring 30mm from the line AB and 50mm from point D. And then part D tells us the midpoints of the lines AB, AD and AF define the oblique plane which contains the seat, draw the elevation and plan of the seat, and then determine and indicate the horizontal and vertical traces of this oblique plane. So for this question here, I'm going to keep it near the top left of the page because I'm going to have a dihedral angle going out here somewhere. I'm going to draw my true shape somewhere over here as well, and then part D is going to involve a plane, so it's going to be kept inside the question here along with the seat too. So there'll be nothing going above, so I'm going to keep it near the top. And looking at my my Y coordinates, the highest point I have is going to be 60mm up for point E. So I could go down maybe about 90mm, we'll say, for my XY line, and then I'll come in roughly about maybe here for my coordinate. Actually I wouldn't be able to, I want to keep it close to the left. So what I'll do is I'll look at the coordinates I have, and my furthest one across is going to be 235, and my closest one is going to be 135. So what I can do is I can start that point there and say that that is going to be my 135mm, and then go from there. So my 135, that's going to be for point F. So for F, 0 is my Y coordinate, so it's going to be on that line there, and then I'm going to go down 60 then for my coordinate F in my plan. So there's F there and F there. Then after that then my next one is E, it's 145, so I'll add 10mm on there. And for E it's up 20 and down 50. Then after that then it's 185 for point D, so add another 40 onto that. And then D is up 0 and down 110. So point D is there and there. Point C is 195, so add another 10 onto that there. And C is up 20 and down 100. And point B is 235, which is 40mm away from C. and that is going to be up 60 and down 10. My last one is going to be A, which is actually 205. So C is 195, which is there. So if I go 10 mil more there, I'll get 205. And for point A, it's up 0 and down 40. And there's point A there, and point A there. So then we have A, B, C, D, so I can connect those all together. A connects to B, B to C, C to D, and then D goes back to A there. And then I have plane A, B, E, F. So A ray connects to B, B connects to E, E connects to F, and then F will connect back to A there. And do the exact same thing in plan. A connects to B, B to C, C to D, and back to A there. And then I have A, B, E, and F there. And for now, I'll keep the inner part here light because I'm going to be putting the seat in during part D. So there's no point in drawing it heavy yet because I need to figure out where my hidden detail lines are going to be, where the seat blocks. The line going down there, and then these two lines here. Excuse me. So that's part A complete for now. Next thing I have is part B then, and it tells you to determine the dihedral angle between the planes. So we've already worked out that AB is the common line between the two. So there. So I'm going to take an auxiliary view out there. So looking in perpendicular to AB. So I want to see AB first of all as a true length. And then just extend these on a bit further. I'll just keep my auxiliary close to my plan, so when I get my second auxiliary I don't have far to go then. And there's my X1, Y1, and as always we've got two views back, one view into my plan, two views into my elevation. So for points A, D and F, they're all on the ground, so I follow D out there, D is on the ground there, follow A out here, A is on the ground there, and then F is on the same line as D. So now all I need is the heights for E, C and B. And from the coordinates, E and C are the exact same height, they're both 20 up. So I follow E out and down there. And same with C, they're on the same line. So I have E and C there. And then the height for B is that height there, follow it down, follow it out, there's B, and when I join B to A, that's going to give me the true length of my line of intersection there. So A connects to B, B connects to C, C connects to D, D will go back to A then, and then we also have A, B, E and F. And there's our first auxiliary view. Next thing we want to do is look along that line of intersection because we want to see AB now as a point. there's AB, and there's CD, E and F. They all share the same line there. Then I have my second auxiliary there, and as always, once again, we go 2 views back. So 1 view back would be into my first auxiliary, 2 views is measuring into my plan. So C and D, they're the exact same distance there and there. I can follow C and D out there. And then E and F share the same distance as well, and follow them out there too. And then the key one I need, the point in between, it's going to be A and B. They're going to be the same distance as well, there and there. Follow them down, follow them out. There's going to be AB. And I join them together. I get my dihedral angle in there, completing part B. Then part C asks us to determine the true shape of the surface ABCD, and on the true shape include a diameter 20 circle for the porthole, given that centre is 30 mm from the line AB and 50 mm away from point D. So in order to get a true shape, I need to have true lengths. If you look at ABCD here, we can see that that is an edge view. If I look perpendicular to that again, I can see that as a true shape. So what I can do is I can look in, for example, perpendicular along here and get the true shape and then mark it. Or another method you could use would be triangulation, where you would turn the shape into 2 triangles and take the true lengths and then basically draw the shape from that. So for this one here, I could do both methods. So for the first one, I'm going to take the excuse me, the triangulation method. So I have A, B, C and D there, and I have A, B, C and D here. For example here, I could take this line here, and what I'll do is I'll use colour to actually show it. Where I can divide this up into 2 different triangles. So I have triangle ABC and I have triangle ACD as well. First thing I need to do is just, for example, take a point up here. I can call that point A. I can take a line, for example, at a random angle, like that there. And I'm going to mark off point C. Or sorry, I'll label this actually as B, sorry. Because I know the true length of that line there. I'm given it already. That is the true length, BC. Or sorry, not BC. AD, sorry, is the true length because it's on the ground. So if I actually change that back to A there, and I can use this as the true length because that line is parallel to the XY line, therefore AD is the true length. So I take that there, go to A, swing an arc to hit that random line, and now I have length from A to D. To complete the triangle, I need the true length from D to C and then the length from A to C. We can see in the question neither of these lines, DC there or DC there, are parallel to XY line. So what I can do is I can make them parallel to XY line. So for example, if I rotate D around, it's now parallel. I take it straight up, C never moves, so D has moved to there, and I connect that to that. That's now a true length. So from D, I swing an arc. Somewhere along there is going to be my point C. Now I need to do the exact same from A. I need to work out the distance from A to C. So you imagine there's A to C there. That's not parallel. A to C there is not parallel. So I repeat the same process again. I'll use the same line from C. I'll rotate A around and take it up to the XY line there. Connect C to that there. And now I have the true length of A to C. Swing it from A, where they cross. I now have my triangle A, D and C there. I can connect D to C there now. Now what I need to do is get my point B. So that's going to be on the triangle ABC. I already have the length from B to C there. Now I need to get the length of B to A, and then I need to get A to B. Sorry, B to A first. So A to B there. Once again you can see that AB there, AB there, neither of them are parallel. So I can look at my auxiliary view here, where I already got the true length. So I don't need to figure it out when I already have it. So from B, swing an arc like that there. So somewhere along there now is point C. And now I need to work out the distance from B to C. So you can see B to C there, B to C there, neither of them are parallel. So what I can do as well, once again, use C as the point, rotate B around. Take it up, take it across, there's where it is there, connect C to there, and that's now the true length of BC. And I can swing that arc there to give me point B, and then as a result I now have the true shape of ABCD. So that's how to get the true shape there for that. Then it tells us there is a porthole to be drawn, and its centre is 30 mm from the line AB and 50 mm from point D. So it is 30 mm from the line AB, so basically what I need to do is go to the line AB, just take a line perpendicular, just say from B there, measure 30 mm away from it, and then go parallel from that. So somewhere along that line now it's going to be the centre, and we're told as well it's 50 mm from point D. So I can take 50 on my compass, swing from D, and where it crosses over it, it gives me my centre point there. And it's a diameter of 20, so it's going to be a radius 10. And there is the porthole now drawn in. It's a diameter 20, and that completes part C. So the last part then, it tells us that the midpoints of the lines AB, AD and AF define the oblique plane which contains the seat. Draw the elevation and plan of the seat, and then determine and indicate the horizontal and vertical traces of that oblique plane. So the first thing we can see there is the seat is 5 mil above the ground. If I just move the question in here, see the seat is 5 mil above the ground first of all. So I can draw that in. So it's along that line there for the base of the actual seat. And then we're told as well it's on the midpoint, each of the points on the midpoint of the lines. So it's on the lines AB, AD and AF. So AF there are on the ground, so that has to be a true length, and AD is also on the ground there, so it's parallel to XY lines, so it has to be a true length as well. If I bisect both those lines, I can get the midpoint there. So taking distance greater than halfway, swing an arc each side. So there's my midpoint for that line there, and then do the same again for A to D. So distance greater than halfway, and that's my point there. So there's for AF and AD, and the last one then I need to find is AB. So I already have the true length of AB here, so I can do what this is, I can bisect this one. And where it hits it there, I can take that back into my plan to give me that point there. And I connect the three together. That's going to give me the position of the seat. Now the seat is 5 mil above the ground, so it's not going all the way down to the ground at these 2 points here. So what I need to do is, I need to take these points up and draw the elevation view of it first before I work out where the line is going across here. I know it's running along these lines, but I need to work out where it hits it off the ground first. So that point there is for A and F. I just call that 1. This point here is 2. This point here is 3. So 2 is along AD. 2 is there. 1 there. And then 3 is along this point here. So if I connect 1 to 3 and 3 to 2, you can see they cross over the 5 mil line at that point there and that point there. So now I can draw in the seat and my elevation and then drop these 2 new points down into my plan. So it's hidden detail there, and then it's hidden detail out to where CD is. And then we can see that part there, we can see that open part there, and then it's hidden detail into that little bit there. And now I can take my 2 new points that I found, this one here down to hit at that point, this point here down to hit that point. and I can now draw that in complete seat in my excuse me, elevation. Now I can see where there's going to be hidden detail underneath this then up to that point. And the last part then, for part D, I have determined the traces of the horizontal and vertical trace of the oblique plane for that seat. So, the traces of the plane we know are the lines formed where an oblique plane, for example, touches off the horizontal and vertical plane. So basically where it touches like the ground and then the wall standing behind, if you were to imagine that being a plane. So we already have 2 points on the plane that are on the ground. We have points 1 and 2. 1 and 2 we found on the ground there when we extended them out. So they're going to be the traces of the plane here, 1 and 2. So extend those out like that. And that's going to be our horizontal trace. Another point we have in our plane is point 3 for the seat. So what we can do is we always go parallel to our trace in our plan. So there's point 3, follow it up like that, going parallel there, take it up, and where 3 is there, take it across to hit it, and that gives me a point on my vertical trace. I can connect that back to there, and there's my vertical trace now drawn in, and that completes the question then.